Alright, we got one more video here that I can work through in between my break. Factoring the sum or difference of two perfect cubes. Alright, so what I mean by that is something like x to the third minus 8. So x to the third is the perfect cube, and 8 is the same thing as 2 to the third power, so it's a perfect cube as well. So the first thing you want to do here is try to identify what am I cubing to get each of these things. So I'm cubing an x, and I'm cubing a 2. Alright, so this is going to factor. Well, we take what we're cubing. We have an x and a 2. Alright, so that goes here and here. You're going to square the first thing here. So if I square x, I get x squared. If I square a 2, I get 4. That goes on the end. Then I multiply the two together, x times 2, and that goes in the middle. And then we use a little mnemonic device to help us remember the signs. So it's same, opposite, and then the last one is always positive. So we started off with a negative, so the first one is the same, the middle one is the opposite, and the last sign is always positive. Okay, so x to the third minus 8 factors just like this here. Okay, let's look at another one. 2y to the third plus 54. So just like with the difference of squares, you always want to check and make sure that you've factored out the GCF first, if there is one. So 2 goes into both of those numbers. 2 goes into 2y to the third, y to the third times, into 54 27 times. Alright, so then we want to check to make sure that these are both perfect cubes. Well, y to the third is obviously y to the third, and 27 is 3 cubed. Alright, so this is going to factor, of course, the 2 stays the same. We're cubing a y and a 3. Y squared, 3 squared, and 3 times y. And same, opposite, always positive. Okay? So the process here is pretty easy. As long as you remember the pattern and you can identify what you're cubing, these are no big deal. Piece of cake. Alright, let's look at our harder one. 512z to the third minus 1. So expect to see some bigger numbers here when you start cubing stuff. 512 is 8 to the third. And you have to recognize that whenever you're solving this, otherwise you'll screw up the problem. So here we were cubing, this is the same thing as 8z to the third power. So we're cubing an 8z and a 1. And 8z squared would be 64z squared. 1 squared is 1. And 8z times 1 is 8z. Same, opposite, always positive. Alright. One little trick here that's interesting to look at is that some of these things, for example, x to the 6 minus 1, sometimes they'll factor in two different ways. So for example here, I could look at this as being x squared to the third minus 1 to the third. It's the difference of two perfect cubes. If I look at it that way, well, this is going to factor, well, I'm cubing an x squared into 1. When I square that, I get x to the fourth. When I square 1, I get 1. And I multiply them together, I get x squared. Same, opposite, always positive. And then notice that x squared minus 1, that's the difference of two squares, so it factors again. And I can break this down like so. Okay, so this is one complete and correct answer. One possibility for factoring x to the 6 minus 1. But let's say that you didn't see this as cubes. Maybe you saw it as x to the third squared minus 1 squared. Well, that's the difference of two perfect squares. It factors a little bit differently. It's x to the third minus 1 and x to the third plus 1. Okay? So then this is the difference of cubes. It factors like this. Right? X minus 1, x squared plus x plus 1. But this is also the sum of cubes, and it factors kind of the same way. X and 1, x squared, x and 1, same, opposite, always positive. Alright? So this is another perfectly good answer, and it's actually the exact same as this. So eventually we'll look at how to factor things by guess and check, and we'll know that this trinomial here that we get when we're factoring cubes is irreducible. We can't factor it in Algebra 2 anyway. But notice that when we have a problem like this where we can solve it two different ways, we can see that comparing these two answers, we know that they're the same because they came from the same problem. That this x to the fourth plus x squared plus 1, it must factor as x squared plus x plus 1 times x squared minus x plus 1. However, you won't ever have to factor anything like that, at least not in Algebra 2. So take note that you can do things in two different ways. Know that you may see a problem like this on the test. So just to watch out. Alright, let's look at a couple more. 729, a to the third, b to the third, minus 343, c to the third. So this has just got a couple more things in it. 729 is 9 cubed. We have an a and a b that we're cubing as well. 343 is 7 cubed, and we're cubing the c also there. Alright, so this thing's going to factor as, well, we cubed a 9ab and a 7c. If I square the first one, I get 81 a squared b squared. If I square the last one, I get 49 c squared. When I multiply them together, I get 63 ABC. Same, opposite, always positive. Alright. Again, it's always a good idea to check to make sure you didn't have a GCF at this step. We can prove that we don't because the only factors of 9 are 3 and 3, and 7 is prime. Nothing goes into 7 and 3, so other than 1. So we know this didn't have a GCF. Alright, let me do one more problem here, and then I'll stop. Let's do this. Thinking real quick. Let's actually make it this. Alright, so notice here that we have a GCF. We can pull out an 8, because 8 goes into both of those things. Alright, and then notice that what's left over, they're both perfect squares. Or, sorry, perfect cubes. I misspoke. Again, if you get confused by looking at the a plus 1 to the third, you can let u equal a plus 1, kind of like we did with the difference of squares. So our problem really that we're looking at is u to the third plus 2 to the third. And that's going to factor as u plus 2, u squared, plus 2u plus 4. Except, remember the same, opposite, always positive. But then take note that we didn't start off with any u's in the problem, so we need to go back and plug in what u is equal to. It was equal to a plus 1. Okay. And then the only thing that really I would do, that's just extra, is I know that a plus 1 plus 2 is a plus 3. Then I have an a plus 1 squared minus 2a plus 1 plus 4. So I might go ahead and combine those. But really, I'm not going to do any more multiplication because that's kind of the opposite of factoring. Some people might break this down further. If you're trying to solve an equation and that's why you're using the factoring, then you're more than welcome to go ahead and distribute this out and try to combine like terms. However, I'm okay with you just stopping here if this is if I'm grading it. So I think that's a perfectly good answer there. Alright, so that's a little introduction to factoring cubes. Hopefully now you've got on the pattern. Remember that SOAP will help you get your signs right. So to get this, you're taking the first thing and squaring it, taking the last thing and squaring it, and multiplying those two together, and that goes in the middle, and then SOAP gets you your signs. Alright, if you have any questions, feel free to leave a comment below, and I'll try to get back to you. Alright, good luck.